All right, good morning, or for sixth period, good afternoon. I'm going to try doing today's lesson as a video lesson, partly because one of my daughters is sick and I might have to be out today, also because I kind of want to see how this works out if you guys can kind of move at your own speed and go ahead and move through the lesson faster for those of you that are ready to, or pause and watch again for those of you who need it a second time. As you can see, we got homework solutions from last night's lesson on. So pause the video at this point, take a couple minutes and look these over, make sure you're feeling good about all of them. Ask questions of your neighbors or of me if you need any help. All right, I'll go ahead and move on to today's lesson. So what we're talking about today are areas, and that's area of a circle, but more specifically area of a certain section of the circle that we call a sector. So we start with our area of a circle formula, and this one should look familiar. It is pi r squared. That's definitely something you've seen before. R stands for the radius, which is the length from the center to any point out on the outside of the circle. And we know pi is a number that goes on forever, but it's equal to approximately 3.14. All right, if we want the area of a sector of a circle, this is a really similar concept to what we did yesterday with the length of an arc. So we're talking about a certain section of the circle. We need a fraction that's going to explain how much of the circle we're talking about. And that's what this piece is here. Measure of the arc out of 360. That's our fraction that sort of tells us we're talking about this much of the circle. And we'll multiply that times the total area of the entire circle. And here's a couple examples of how that plays out. First step, when you get a problem like this, you notice you're only looking for the area of this green shaded section here, and its angle is 60 degrees. Okay, but before we can really get to the sector area, we need to get the area of the entire circle. And since our area of the circle is pi r squared, you see that off to the side here, we just need to square the radius, and in this case, radius is 10. So 10 squared will become 100. Area of the entire circle here is going to be 100 pi. So if I can get my pen out, get that filled in. 100 pi, which if you wanted to turn it into a decimal would be equal to about 314. But we're not going to do that just yet. Area of a shaded sector, we have to use our fraction. This is our fraction out of 360. So we'll do 60 out of 360. And we'll take that fraction and we'll multiply it by our total area of 100 pi. Now, here's where we have to think about what kind of answer we want. If we want a fraction, a decimal answer, we could probably throw this fraction into a parenthesis and go ahead and type this right into the calculator and it would spit out an answer for us. But if we want a specific answer, an answer in terms of pi, this is where it would be helpful to simplify this fraction a little bit. 60 out of 360 is actually just 1/6. So if we think of it that way as 1/6 of 100 pi, we get a little closer to knowing the answer in terms of pi. We can then multiply that 100 into the numerator and get 100 over 6 pi, and you can leave the pi off to the right, or you can put it in the numerator with the 100. It really doesn't make a lot of difference. But 106 would also still simplify even more. They're both even numbers. So you could turn this into 50 pi over 3. And at this point, 50 is not a multiple of 3. So you're not simplifying this any farther. But what you could do is put it into a decimal form. Okay, and if I want to put this into a decimal form, here's how I'm going to do it. I'm just going to pull out the calculator, kind of clear out what's in there. And if I want to put in 50 pi over 3, I can either use parentheses for my 50 pi to make sure the calculator understands that those are both in the numerator, and then divide it by 3. Or if you're familiar with the alpha y equals feature, in fact, this is an easy time to show you that. Alpha y equals numerator, denominator. This will actually put it into something that looks like a fraction. You'll see it'll come out the same either way. You're looking at 52.4 for this answer. So this is an answer that's a completely valid answer. It's just rounded a little bit, 52.4. 50 pi over 3 is the simplified answer in terms of pi. So depending on what you're looking for, either one could be helpful. All right, this next one I'm going to move through a little faster. We've got a total area, because the radius is 3, of 9 pi. Okay, so total area of 9 pi, and that's coming from pi r squared, and with an r of 3, we square it to make 9. But we need to multiply that times 150 out of 360, and that's going to simplify down quite a bit. And again, if you just want a decimal answer, you're at a point here where you could type this into the calculator and get that decimal. But if you want to simplify a bit farther, trying to see what would go into both of these, I think 30 would go into it. So when I look at that, I think I'm seeing 5/12 here. So 5/12 times 9 pi. That would be a simplified version of our original fraction, 150 out of 360. And if I multiply that 9 pi into the numerator, I have 45 pi over 12. But 45 and 12 are both multiples of 3, so I actually think I can simplify this down a little bit farther. So if we were to turn this into 15 pi over 4, that would be even better. And 15 and 4 don't really have anything in common, so I think we're pretty well simplified on that. And if you want to turn that into a decimal answer, you can just do your 15 pi, and this is another option if you don't like doing the parentheses. Just multiply 15 pi and then do divide by 4. And that'll get the 15 and the pi both together multiplied, and then all divided by 4. So 11.8 would be a good decimal answer here. Now, as far as the first section on the homework and the questions you might see on the quiz tomorrow, this is the type of stuff you're going to be accountable for. But we do want to go ahead and show you a few more challenging problems that hopefully get you thinking a little bit and get you ready for the later homework problems. All right, I'm going to skip this one because we did a couple examples like this. Quick heads up, if you ever do get a question like this one, you've got a pizza's radius at 4 inches, which means total area is 16 pi from pi r squared. One slice, you've got 16 pi for the total pizza. All you have to do is divide it by the number of slices, which in this case looks like it would be 8. So you're going to get an answer of 2 pi. There is no need to calculate the angle in the middle and go back to using a fraction out of 360. All the slices are equal, so simply divide it up. All right, a segment of a circle. This is another thing you get asked about, and you see here the shaded portion is not the entire sector. It's this kind of extra curved piece out on the outside, and you could get the area of this shaded piece by finding the area of the whole sector and then subtracting away whatever the area of that triangle is. And in this problem, we don't have enough information. We can't actually do it, but I'll show you. Okay, what I'm actually going to do on this one is I'm just going to go ahead and fill in a radius, and that'll give us something that we can work with. Let's say the radius is 5, because this is a nice setup here with a nice easy triangle to calculate the area of. So we get the area of the whole circle with a radius of 5 would be 25 pi. But to find the area of the sector, we'd have to multiply that times 90 out of 360, because this box indicates a 90 here. And 90 out of 360 is really just 1/4. So when we look at that, 25 pi times 1/4 is just going to be 25 pi over 4. This is the 25 pi over 4, the area of the sector, which would include this shaded section, but then again, it would also include the triangle. Triangle is not supposed to be shaded here, so what I have to do with this 25 pi over 4 is subtract whatever the area of that triangle is. So I'm going to do 25 pi over 4 minus the area of the triangle. And the area of this triangle, because every radius is the same, we know this radius would be a 5 also. So we're basically looking at half of a 5 by 5 square. Um, and your area of a triangle formula, of course, is 1/2 base times height. So 1/2 of 5 times 5, which is 25. So we have this. And if we want to get this in some kind of a fraction form, we'd have to turn this one into fourths. So let's do that real quick. We have 25 pi over 4 minus 50 over 4. And we can bring that together as one fraction. That's just 25 pi minus 50 all over 4. But some of you probably prefer a decimal. It does give you a little better sense of exactly how big it is. And this thing's kind of messy. So what I'm going to do is just pull out the calculator real quick and do 25 pi minus 50 all over 4. This is a great time for that alpha y equals feature. Of course, you could do it with a parenthesis as well, but this is a nice way of getting it to look exactly like it looks. So 25 pi minus 50 all over 4. Let's see what it tells us. 7.1349. So about 7.1 if you wanted your answer as a decimal. Last step, just say to yourself, does this make any sense? If the area of the whole circle was 25 pi, which is going to be a little more than 75 since pi is a little more than 3, uh, this is about, maybe a little less than 10% of that. But I can buy that because this is really only a small sliver of the circle that's been shaded here. So this is how you go about finding the area of a segment of the circle. You will get a couple homework problems on that. Don't expect anything like this on your quiz tomorrow. Possibly something deeper in on the test. All right, that should get you what you need. If you are interested, I do have one more challenge problem on here. If you would like to pause the video here and take a look at this challenge problem, you're welcome to, and I will be happy to look over your work and let you know if you've gotten it correct. The homework for tonight is going to be right here, page 399, 7 through 13, 17 to 19, and 22 through 27. That'll be due tomorrow, which is Thursday. Uh, and you might have seen real quick this IXL practice. This is not required, but if you're interested, you can get some extra practice on IXL at U.4. All right. Have a great day, and let me know if you have any questions.